This is a video from section 2.1 in a linear algebra class. Let A be an n by n matrix. The determinant of A is a number associated with the matrix A. Now, let's look at specifically the determinant of a 2 by 2 matrix. So what I'm going to do is I'm going to let A equal the matrix in which the entries in the first row are A and B. The entries in the second row are C and D. And I want the determinant of A. So the determinant of A is equal to A times D minus B times C. So notice I multiplied the entries along the main diagonal and multiplied the entries along the other diagonal and subtracted the results. And with that, let's take a look at example 1. Suppose I ask you to evaluate the determinant of A minus 3, 5, negative 3, A minus 2. So in other words, I'm evaluating the determinant of a matrix in which the entries in the first row are A minus 3 and 5. The entries in the second row of that matrix is negative 3, A minus 2. So if we take the determinant of this matrix, we get A minus 3 times A minus 2. So I multiplied the entries along the main diagonal, and then I'm going to subtract off the product of the entries along the other diagonal. So in other words, I'm going to subtract 5 times negative 3. So again, the determinant of this matrix is A minus 3 times A minus 2 minus 5 times negative 3. So I get A squared minus 5A plus 6. So this piece is A minus 3 times A minus 2. And then remember, negative 5 times negative 3 is positive 15. So I have to add 15. And when I simplify, I should come up with A squared minus 5A plus 21. That's example 1. Let's take a look at example 2. It says, find all values of lambda for which the determinant of A is equal to 0. So this will pop up later on in this course, and it will also pop up in differential equations, this idea, okay? Now, I'm going to let A equal the matrix in which the entries in the first row are lambda minus 2 and 1, and the entries in the second row are negative 5 and lambda plus 4. So we need to find the determinant of A. The determinant of A is equal to lambda minus 2 times lambda plus 4, right? So I multiplied the entries along the main diagonal, and then I'm going to subtract 1 times negative 5. So notice how I multiplied the entries along the other diagonal accordingly, right? And so when I multiply this out and simplify, I get lambda squared plus 2 lambda minus 8, right? So this piece is lambda minus 2 times lambda plus 4. And then negative 1 times negative 5 is positive 5. So notice here on the second line, I added 5. And so this is lambda squared plus 2 lambda minus 3. But now I need to set the determinant of A equal to 0. So that says lambda squared plus 2 lambda minus 3 is 0. If I factor the left side, I get lambda plus 3 times lambda minus 1 is 0. So lambda equals negative 3 or lambda equals 1. And so this is the set containing negative 3 and 1. That's the solution to this example. Okay. Now, the inverse of a matrix A, which we're calling A, B, C, D, can be expressed in terms of the determinant. So A inverse is 1 over the determinant of A times the following matrix. So notice the entries in matrix A along the main diagonal, right? And so I'm going to interchange those entries. So notice how D is in the upper left-hand corner and A is in the lower right-hand corner. And if we look at the entries of A along the other diagonal, when I get A inverse, I change the signs. So notice the entries along the other diagonal are negative B and negative C. And let me give you a quick example of this. Suppose A is the matrix, and I have 4, 5, 6, 7. Okay? The determinant of A is 28 minus 30, right? Which is negative 2. So what's nice about this is getting A inverse is really straightforward. To get A inverse, it's going to be 1 over negative 2. And then I'm going to multiply by the following matrix. So notice the entries along the main diagonal of A. I'm going to interchange them. So in other words, I'm going to write 7, 4. And then I look at the entries along the other diagonal. And I'm just going to change the signs of those entries. So in other words, this entry up here will be negative 5. This entry down here will be negative 6. And I claim that is A inverse. And a good way to check is if I take A and multiply by A inverse, you will see that I get I back. And remember, I is the identity matrix, which is equal to 1, 0, 0, 1. This is the identity for 2 by 2 matrices. And quite similarly, if I take A inverse times A, I claim that will also be I as well. Okay. Now, this is the idea of how it works, okay? I'm going to let A equal the matrix A, B, C, D. And remember, I want to show that A inverse equals 1 over the determinant of A times, I'm going to put D, negative B, negative C, A. So I want to show that A inverse is that, okay? Now, this is what we do. So I'm going to take the matrix A, and I'm going to join it up with the identity matrix. And what you want to do is you want to perform a series of elementary row operations so that when we're done, the identity matrix is going to be on the left-hand side, and whatever's left over on the right-hand side, I claim is going to be the inverse, which I claim will be this. Okay, now what's the strategy in order to do this? I'm going to take row 1 and multiply it by 1 over A. Of course, right, we're going to assume, for sake of argument, that A does not equal 0. So I'm going to take 1 over A, row 1, and I'm going to put the result back into row 1. Okay? Now, when I do that, I get the following. I get 1 B over A, dot, 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 1 over A, 0. And then the second row does not change. Now, from here, I want to turn this entry that I'm pointing at into a 0. What do I do there? I'm going to take negative C, row 1. I'm going to add it to row 2. I'm going to put the result back into row 2. Now, let's see what happens there. When I do that, I get 1 B over A, right? And then I get 1 over A, 0. By design, this entry is a 0, okay? Now, this next entry is going to be D minus BC over A. Then here I get negative C over A, 1. Now, let's do a little bit of work here. D minus BC over A. I'm going to make this D over 1. So this is AD over A minus BC over A. Right? And so this is AD minus BC divided by A. So this is 1 B over A, 1 over A, 0. And then 0 AD minus BC divided by A. Okay? And then I just have to create a little bit of room here. 1 over A, 0 is over here, negative C over A, and 1 is over here. So I didn't do anything different there. Okay? Now, I want to turn this entry here into a 1. Now, what am I going to do there? I'm going to take A over AD minus BC, row 2, and I'm going to put the result back into row 2. Now, let's see what we get here. We get 1 B over A, 0, 1. That's the left side. The top row doesn't change, so this should be 1 over A, 0. Now, the bottom row, now notice, if I take negative C over A and I multiply it by A over AD minus BC, the A's will cancel. And we should get negative C over AD minus BC. Okay? And then the other entry, right? This is going to be A over AD minus BC. Okay, we're almost done. Now, look at this. I want to turn this entry into a 0. How do I do that? Well, I'm going to take negative B over A, row 2, add it to row 1, put the result back into row 1. So we get 1, 0, 0, 1 for the left side. For the right side, now notice how the bottom doesn't change, right? So the bottom should be negative C over AD minus BC. And then this should be A over AD minus BC. So that's okay. Now, the top is the fun, right? So on the top, right, I'm going to get the following. So I'm going to take negative B over A times this entry and then I'm going to add it to 0, right? But notice how the a's cancel. And I'm going to get negative b over AD minus BC. Okay, that's the top right. We're almost done. Now let's look at the top left. So I'm going to take negative b over a times this entry. And then I'm going to add 1 over a. So let's do that down below. I'm going to take BC over AD minus BC, right? And then I have to add 1 over a. And by the way, there's an a down there as well. So this is being multiplied by a. And then I'm going to add 1 over a. Now, I need to get a common denominator. And so over here, I'm going to multiply numerator and denominator by AD minus BC. Okay? And so when I combine, I get BC plus AD minus BC divided by A times AD minus BC. But the BC's cancel, and we get AD over A times AD minus BC. But notice how these A's cancel. So it's not immediate, all right? But it turns out you get D over AD minus BC. Now, check this out. So what does that tell me? That tells me A inverse is the matrix. Now, the entries in the first row are D over AD minus BC. And then if we look, we get negative B over AD minus BC, right? And then we get negative C over AD minus BC. And then A over AD minus BC. Now, I can pull out a 1 over AD minus BC. And when I do, I get D, let's write that again. So D, negative B, negative C, A. But note, the determinant of A is AD minus BC. And so, therefore, A inverse is 1 over the determinant of A times the matrix D negative B negative C A. So we want the determinant of A to not equal 0 for this to make sense. And I assumed for sake of argument A wasn't equal to 0 also for this to work. Now, let's take a look at one more example for this video. And we'll look at example 3. I'm going to let A equal the matrix. Now, in the first row, we have negative 5, 7. In the second row, we have negative 7, negative 2. Okay? Now, first of all, what's the determinant of A? Now, that's a quick calculation. You get negative 5 times negative 2 minus 7 times negative 7. But this is 10 plus 49, which is equal to 59. And so A inverse equals 1 over the determinant of A. So in other words, 1 over 59. So I'm going to take the entries along the main diagonal and swap them. So I put -2 up here. I put -5 down here. And then I'm going to change the signs of the entries along the other diagonal. So I'm going to put -7 up here and 7 down here. I'm done. And so here you get the matrix -2 over 59, right? If I take this number, basically what I'm doing is taking that number and multiplying it by every entry within the matrix. So I get -2 over 59, -7 over 59 for the first row, and then I get 7 over 59, and then -5 over 59 for the second row. Now, a good exercise would be to take A and multiply it by A inverse and check out. Do you get the identity matrix back? So, okay, that'll conclude this video for section 2.1. And we looked at the determinant of a matrix and did 3 examples. Thank you.